All right, this is a nice one because now we're working on the real numbers, and this is going to be very similar to some things that you're going to think about in real analysis. It's like a pre-real analysis proof. You have to prove that if x and y are positive real numbers, I forgot the positive word positive, that's really important, then square root of x plus y is never equal to square root of x plus square root of y. There's many people that think that these are equal because I've had them in class, but they're not, and I'm going to prove it. If you approach this directly, like write down the steps, if this, then you're not going to have anything to work with your hands because all you're given is that x and y are real numbers. That's your no. And what you have to show is quite complicated. So, contrapositive and proof by contradiction are both places where what you have in the no is very little and what you have to show is awkward, then maybe you can reverse the order. And this is a contradiction. It's better done by a contradiction proof because either that last part right up here is equal or isn't equal. It just is or isn't. So I think we said that in class. It's going to be attributed to one of you here. So this leads me to believe this might be a nice proof by contradiction. So that one is not assembled the same way as the other ones. What we do is we take the show, assume the opposite, and try to arrive at something illogical. So let's assume on the contrary that these two things are equal. And let's do some 9th grade or 8th grade or 7th grade algebra depending on when you took it. Let's square both sides or scare both sides. There we go, scare both sides. We get this thing. And I get 0 is equal to 2 square root of x times y. And that statement's only going to be true if x and y are both, one of them are 0. But that's a problem since the statement should hold for positive x and y. And now we arrive at a contradiction. And we write our closing statement. Thus, our assumption that this was equal for all positive real numbers is false. And so the opposite is true, that they're not equal. And this symbol right here, the upside down A, is a symbol that means for all positive numbers, x and y.